Okay, quick question before we even start. No pressure. In the last 24 hours, how many times do you think you used artificial intelligence? Go on. Guess. 5, maybe 10. The real answer is probably closer to 100. And I'm going to prove it to you by the end of this video. Here's the funny part though. Almost nobody who uses AI 100 times a day can actually say what it is. We toss the word around, AI this, AI that. But if someone stopped you and asked, what is it really? Most of us just freeze. So that's our little mission today. 10 minutes from now, you'll never freeze on that question again. Let me start with something you've literally seen this week. You open Swiggy, place an order, and the screen goes, arriving in 32 minutes. Most of us just close the app and carry on. But stick with me and actually look at that number, because it's sneakier than it seems. First, it's not a fixed timer. Order the same biryani, same place, an hour later, and it might say 41. Something's changing that number based on the moment. Second, and this is the bit nobody thinks about, there's no human doing this. Nobody at Swiggy is sitting in a control room going, Rajesh ordered, traffic's bad, let me type 32. At millions of orders an hour, no chance. So something else must be making that case. Not a person, not a fixed timer, something new. And figuring out what that something is, that's the whole story of AI. So let's try to build this ourselves. If someone handed you the job, you'd probably think like a regular programmer and just write rules. Restaurants busy? Add 5 minutes. Raining? Add 7. Nobody enjoys a scooter ride in Bombay rain, fair enough. Drivers more than 2 kilometers out? Add 4 for traffic. Weekend? Add 3. And honestly, this feels great. For the first 20 orders, it actually works beautifully. This is how software has been written for 50 years. A human sits down, imagines every situation, writes a rule for each one. You're the brain. The computer just does as it's told. And then reality strolls in and slaps your little program right across the face. Because what about a rainy Saturday during lunch rush on a festival? When the driver's juggling 2 other orders and the kitchen's just slow today. Those combinations explode into millions of possibilities. And every time you patch one situation, 2 more break. I've watched developers lose whole weeks to this. You end up with thousands of rules arguing with each other. And the app still gets it wrong. On top of that, reality keeps moving. New restaurants, new areas, festivals, road closures, faster than any human could ever write rules for. That's the wall. And that's the exact moment clever engineers stopped and went, wait, what if we've been doing this completely backwards? Because the honest truth is, no human can write all the rules. Reality is just too gloriously messy. So here's the flip. And genuinely, it's one of the most beautiful ideas in all of computing. Old way, a human writes the rules. New way, the computer discovers them. Old way, you tell the computer what to do. New way, you just show it what already happened. And the old way breaks on the situations you forgot. But the new way actually gets better the more examples it sees. Think about how a 3-year-old learns what a dog is. You don't hand the kid a rule book. 4 legs, fur, tail, barks at frequency X. You just point. Dog, dog, there's a dog too. And after enough examples, the kid just knows. Even a dog they've never seen. Nobody wrote a rule. The pattern got soaked up from examples. Exactly that is the shift. From telling to showing. So how does a computer actually learn from examples? 3 simple steps. And I promise, none of them are scary. Step 1. Data. You gather a big pile of past examples. For Swiggy, that's every order they've ever delivered. Step 2. Pattern. The computer studies that pile and spots the hidden connections. And this bundle of patterns has a name. We call it a model. Step 3. Predict. Your new order goes in and out pops a prediction. 32 minutes. Data pattern predict. Honestly, hold on to just those 3 words and you already get the backbone of every AI system on earth. Yes, including ChatGPT. Now let's slow down and look at each step with our Swiggy example. Step 1. The data. Picture a giant spreadsheet, 10 million rows long. Every row is one real delivery that actually happened. Like this. Domino's, clear evening, short hop, light traffic, Ravi driving, took 28 minutes. This one. McDonald's, pouring rain, far away, brutal traffic, 47 minutes. Behrus, clear skies, medium distance, medium traffic, 34. Burger King, clear, super close, light traffic, Ravi again, 22 minutes. But here's the column that matters. This last one. Actual time. What really happened? Think of it as the answer key at the back of the textbook. The computer gets to see the questions and the answers millions of times over. That's the raw material. So, what does it do with all of it? Step 2. The one everyone assumes is magic. It really isn't. It's just very, very fast noticing. Let me show you what finding the pattern actually means. First, take all those past orders and plot them on a simple graph. Distance across the bottom, delivery time going up. Each dot is one past order. And just by eye you can already see it. Farther usually means longer. The dots slope up to the right. Now here's the clever bit. The computer draws the single line that best fits all those dots, right through the middle of the cloud, as cleanly as it can. Nobody told it the slope. It worked that out itself just from the dots. And that line, right there, that is the pattern. And this thing the computer drew has a name. We call it a model. You'll hear that word for the rest of your life now. So picture this every time. A line drawn through millions of past examples. That's all a model really is. Step 3. The payoff. And this part is beautifully simple. We've already got the model, the line, right there. So we don't do anything fancy. We just read the answer of it. Your new order has a certain distance. Go up from that point on the bottom axis until you hit the line. That's where you land on the pattern. Then slide across to the time axis. 32 minutes. That's the number on your screen. No rule was written. No human typed a thing. The model just read your answer off a line it learned from millions of past deliveries. That's the something else we went hunting for at the very start. So now, finally, we can say what AI actually is. And this time it'll mean something because you just watched it happen. AI is software that learns the pattern from examples instead of being told the rules. Let's read it slowly together because every word's pulling weight. Learns. It improves on its own. We didn't program it step by step. Pattern from examples. It studied millions of past cases. That was our cloud of dots. Instead of being told the rules. And that's the whole revolution. No human wrote the logic. The machine figured it out. 10 minutes ago that sentence would have been just words. Now you've watched it happen with your own biryani. That's the difference between knowing a definition and actually getting it. Let me make the contrast really land, because this is the line between two whole worlds. Normal software is like a calculator. 2 plus 2 is 4, every time forever. A human wrote that rule decades ago and it never changes. Predictable, exact, rigid. AI is the opposite kind of tool. The more data you feed it, the sharper it gets. It actually improves over time. It's messy, it's a bit probabilistic, it sometimes slips up. But it can handle problems no human could ever write rules for. Like say, predicting a biryani's journey across a rainy city. And neither one is better. They're just different tools for different jobs. You wouldn't use AI to add 2 numbers. And a calculator's never going to predict traffic. Okay, 2 words. I want you to genuinely tattoo these somewhere in your brain because they're the key to this whole series. Rules versus patterns. Old software runs on rules. Mechanical, written by a human, rigid. AI runs on patterns, learned from data, organic. It bends to fit the real shape of the world. And everything we cover over the next 29 episodes, neural networks, ChatGPT image generators, all of it lives on the pattern side of this line. So from today, here's your new habit. Every time you hear AI out in the wild, a headline, your boss, an ad, quietly swap it in your head for a thing that learned a pattern. You'll be right almost every time, and you'll get it better than the person who said it. Now, I remember my promise at the start that you use AI close to 100 times a day. Let me pay that off. Watch how fast this goes. Google Maps saying you'll arrive by 6:42. Same trick as Swiggy. Patterns from millions of past trips. Gmail quietly slipping spam into the spam folder. Pattern, not rule. YouTube serving up the next video that somehow keeps you watching 3 more hours. Yep, pattern. UPI catching a dodgy payment in the half second before your money moves. Instagram's explore page that, let's be honest, knows you a little too well. Your phone camera finding faces in a crowd and blurring the background in portrait mode. Every single one. Pattern, not rule. And that's just 6. I could keep going for 20 more minutes. That's your 100 times a day. You've been living inside AI all along. Today you just learned to see it. So let's lock it in. 4 things and you're done. 1. Traditional software means humans write the rules. 2. AI means the computer learns the pattern from examples. 3. It happens in 3 steps: data, pattern, predict. 4. That learned pattern is called a model. If those 4 land for you right now, I promise you're already ahead of most people who work in tech but never stop to get the basics. Genuinely. And you might have already felt this itch, I cheated a tiny bit today. All through this video, I kept saying this magic little phrase: the computer finds the pattern. And every time I just breezed right past it. But how? How does a machine, which is really just doing maths on numbers, actually draw the right line through millions of messy real world food orders? Is it magic? Is it just averaging? Is it secretly intelligent? That question, how the learning actually happens, how the model knows where to draw the line, that's the real heart of this whole subject. And it's exactly where we go next. Next time, we untangle the 4 words everyone mixes up and uses wrong: AI, machine learning, deep learning, and generative AI. After that one, you'll be the person at the table who actually knows the difference. It's a quick one, and it finally makes all 4 click. And if something clicked today, if AI feels even a little less mysterious than it did 10 minutes ago, do one thing for me. Send this to that one friend or cousin who keeps asking, Yar, what even is AI? You'll save them the confusion and you'll sound brilliant. See you in the next one.